I'm going to take a brief moment to go over a bonus spreadsheet project that you can do. And in this case, we're going to take a look at how spreadsheets can help you look at inflation and the price of things over time. So in our example, we have an original price of something. It's $14. We'll say that that is a Donato's pizza. You would type that in. You would also type in your inflation rate. So a Donato's pizza today, when you're age 16 in year 2022, or whatever year this might be when you're doing this project, has a price of $14. But the inflation rate, 3%, is the rate at which prices go up. So if the pizza follows the inflation, after 1 year the price would be about $14.40, and then after 10 years the price would be $18.81. Your job is to program this spreadsheet so that the user will enter in, they will number type in an inflation rate and a price of something, and that price will show up here as an original price, but then your spreadsheet will do the math all the way down here, and in fact, all the way down into a second page until you get to age 60, and that will be the price of the item at age 60. So in this case, the pizza, if we follow a 3% inflation rate, will cost $51.40 when you're age 60 in perhaps the year 2066, depending on what it is for you. That final price, so that the user doesn't have to scroll down through the spreadsheet, will just be connected to that cell. So there'll be a formula in that cell where that final price shows up. So in the end, if we decide, okay, we want to look at a car, and a car costs, say, $25,000, and we think the inflation rate for cars is going to be 3.2%, we'll plug in a 3.2 into here, 25,000 into here, and we're going to get a new price for that car when you're 60 years old. That's what the spreadsheet's going to do. The big deal is the user types in numbers, you've done all the programming here, final answer pops out here. But to do the programming well, you have to understand a little bit about the math behind percentages. And that's what we're going to cover next. We're going to take a quick look at the mathematics of percent increases or decreases. And now before we do this, realize that there's about 173 different ways for people to do percent computations. The way, or the two ways that I'm going to show you, are ways that I think might just be better for your spreadsheet programming. So let's say we had something that was $40 and it was increased by 5%. 5% means 5 out of 100, or as a decimal, 0.05. So most people are good going from here to here. So what you do is you take your original $40, you multiply it by the percent, and you get a $2. That means your $40 is going to increase by $2 for a $42 final price. 32,000 increased by 16%. 16% as a decimal is 0.16. 32,000 times that decimal gives me the 5,120, which is the raise in price. Original price plus raise in price, new price. Or you could have a decrease. $800 decreased by 7%, which is 0.07 as a decimal. Multiply the 800 by the decimal, you get a $56 decrease. 800 minus 56 is 744. The dilemma for you is, how do you take that mathematics and make it show up to do the right things for your spreadsheet? As you're doing this spreadsheet, if you need to have other columns over here on the side that go along with this, in other words, more columns than this, go right ahead. The bottom line is, can you get a correct final answer? Because in this spreadsheet, you're going to have the percent or the price increase happening over and over and over and over. That's the purpose of spreadsheets. They do the heavy math for you, so you don't have to do repetitive calculations. So everything I've shown you probably should be enough to get that spreadsheet going, but it is difficult programming, which is why this is a bonus spreadsheet. However, I want to show you just another way to do percents, and if this turns out to be something you can use on a spreadsheet, fine, or you can just use the previous stuff. But an increase by 5%, like we did previously, is 40 times 1.05, and the way I think about that, 100% plus 5% is 105%. Putting that as a decimal is 1.05. Boom, boom, boom. Increase by 16%. 100% plus 16% is 116%. There it is as a decimal. 32,000 times that. Boom, you're done. It's kind of just a shortcut of the steps I showed you originally. 800 decreased by 7% means 100% minus 7%. 93% as a decimal. 800 times a decimal. Boom, final answer. You do whatever method you need to do so that the user can input a price, an inflation rate, and then the spreadsheet spits out a final price, boy, like 40, 45 years down the line. Enjoy.